Welcome to the deep dive. Today, we're exploring the surprisingly nuanced world of air compressors and vacuum pumps. You know, those workhorses you see in workshops, hospitals, even kitchens. Turns out they're more than meets the eye.
Absolutely. And while they both deal with air and pressure, the way they do so opens up a world of interesting applications.
Right. I dove into that article you sent, difference between an air compressor and vacuum pump. And I have to say, I was struck by how much they share in terms of technology. Scrolls, screws, reciprocating mechanisms. It's like they're built with the same toolbox.
It's a bit like finding out a chef's knife can prep sushi and carve a turkey.
Yeah.
Same tool, radically different techniques.
Yeah.
What we're seeing here is a brilliant example of engineering principles applied in opposite directions.
Okay, love that analogy. So help me wrap my head around this. How can similar components achieve such different results?
It's all about the direction of airflow. Think of a simple piston. In a compressor, it pushes air into a smaller space, increasing pressure. But reverse the piston's movement, and suddenly it's drawing air out, creating a vacuum. That reversal is key.
So one pushes, one pulls, but the article mentioned something about turning one into the other. That's where my brain started to short circuit.
It seems almost counterintuitive, doesn't it? But imagine reversing the gears of a clock, the same mechanism, just running in reverse. With some clever adjustments, you can manipulate the airflow within these machines to achieve the opposite effect.
Okay, that's starting to click. But this difference in airflow direction, how does it impact what these machines can handle? I mean, we're not just talking about air here, right?
Exactly. This is where understanding the properties of matter comes in. Air compressors excel at moving compressible materials, primarily air and gases. Think about inflating a tire. You're forcing more and more air molecules into a confined space, increasing the pressure.
Makes sense. You can't really compress a liquid the same way, can you?
Exactly. Liquids are essentially incompressible. That's where vacuum pumps shine. Instead of relying on compressing the material, they create a low-pressure environment. This void draws in whatever's around it, whether it's air, gas, or even liquids.
So it's not about squeezing, it's about creating a space for things to rush into.
Precisely. Imagine sucking liquid through a straw. You're not compressing the liquid, you're lowering the pressure inside the straw, allowing atmospheric pressure to push the liquid upward. Vacuum pumps work on a similar principle, just on a larger scale.
That's a really clear way to visualize it. So we've got one machine pushing, one pulling. What are the practical implications of these opposite actions?
Well, for one, storage becomes a key differentiator. An air compressor needs a tank to hold all that pressurized air it generates, ready for use. Think of it like a reservoir of potential energy. A vacuum pump, however, often releases the extracted air or fluid directly. You don't need to store a vacuum.
So a compressor needs a piggy bank, but a vacuum pump just spends it as it goes.
You could say that.
Yeah.
Now, what about measuring their performance? This is where it gets even more interesting.
Yeah, I was wondering about that. You can't just use a ruler, right?
Not quite. The article highlights a key difference. Air compressors maintain a relatively consistent output. Think of it like a steady stream of water. But a vacuum pump's flow rate actually decreases as the vacuum pressure increases.
Wait, so the harder it works, the less it can pull in? That seems counterintuitive.
It's all about pressure differentials. At the start, there's a big difference in pressure between the inside of the pump and the outside atmosphere. This difference allows for rapid airflow, but as the vacuum strengthens, the pressure inside drops closer and closer to zero, while the outside pressure remains the same.
So that shrinking pressure difference creates more resistance.
Exactly. It's like trying to suck the last bit of milkshake through a straw. It takes more effort because the pressure difference is minimal.
Okay, that makes sense. But if a compressor's output is like a steady stream and a vacuum pump's is like a fading gust of wind, how do we measure them accurately?
This is where we need different units of measurement. The article mentions cubic feet per minute, or CFM, for air compressors. It's all about volume, how much air they can move within a specific time. Vacuum pumps, however, are measured in millibars, or millbar.
Millibars. That one flew over my head a bit.
It's essentially a unit of pressure. And with vacuum pumps, we're measuring how low they can drop the pressure in a given space. The lower the millibar reading, the stronger the vacuum.
So compressors are measured by how much they pump out, and vacuum pumps are measured by how empty they can make a space.
Precisely. One is about output, the other is about achieving a specific pressure level. It's a subtle but crucial distinction.
Okay, I think I'm starting to see the bigger picture here. Different goals, different ways of measuring success. But I have to circle back to that whole conversion thing. Is it really possible to turn an air compressor into a vacuum pump? What kind of sorcery is this?
It's more about clever engineering than sorcery, but I understand the sentiment. The article briefly mentions a DIY approach. And while it might sound like a simple swap, there are some key details worth unpacking.
Okay, so walk me through it. What's involved in this transformation?
The basic idea is to redirect the airflow. Instead of forcing air into a storage tank, you'd be pulling air from a connected hose. This involves some disassembly, rerouting the hose to the cylinder intake, and ensuring an airtight seal throughout.
So basically some plumbing with a side of epoxy.
In essence, yes, but the devil's in the details. The article highlights the importance of using strong sealants to prevent leaks. Remember, any air seeping in will compromise the vacuum. You might even need to drill new holes for the hose connection, depending on your compressor's design.
Sounds like more than just a weekend project. You'd need a good grasp of the mechanics involved.
Absolutely. And this is where understanding those scroll, screw, and reciprocating mechanisms we mentioned earlier becomes crucial. The article glosses over them, but these internal components are what actually move the air.
Right, we've been talking about airflow direction, but we haven't really dug into how that air is manipulated. It's like we've been discussing the plot of a movie without mentioning the actors.
A perfect analogy. And just like a movie needs skilled actors to bring the story to life, these machines rely on those precisely engineered mechanisms to create the desired pressure changes. Each type, scroll, screw, reciprocating, has its own unique way of compressing or evacuating air.
So this DIY conversion isn't just about switching hoses, it's about understanding the heart of these machines.
Precisely. You're essentially re-choreographing the dance of those internal components to achieve the opposite effect.
That's fascinating. But let's shift gears a bit. We keep mentioning this article, but I realize we haven't talked about the source itself. Sunrise Metal, right? What do they have to do with all of this?
Ah, good catch. The article is actually from their website. Sunrise Metal manufactures parts for both air compressors and vacuum pumps. They specialize in a process called die casting, which is how they create those intricate metal components.
Die casting. That rings a bell, but I can't quite place it. Refresh my memory.
Imagine pouring molten metal into a mold that's the essence of casting. Die casting takes it a step further by using high pressure to inject the molten metal into a reusable steel mold, or die. This creates incredibly precise and durable parts, ideal for machines that experience a lot of wear and tear.
Ah, so that's how they get those complex shapes and tight tolerances needed for these machines. It's like 3D printing with molten metal.
Exactly. And the article highlights Sunrise Metal's expertise in creating parts for medical-grade air compressors. This means they need to meet incredibly stringent standards for precision, cleanliness, and reliability.
That makes sense. We're talking about machines used in hospitals, after all. Lives could depend on them working flawlessly.
Precisely. And this attention to detail, this deep understanding of the manufacturing process is likely what allows Sunrise Metal to create parts for both air compressors and vacuum pumps. They understand the nuances of these machines at a fundamental level.
Okay, that's really cool. So we've gone from redirecting airflow to die casting intricate metal parts. What I'm gathering here is that these machines, while seemingly simple on the surface, are actually marvels of engineering and precision manufacturing.
Absolutely. And their applications are just as diverse. We've touched on a few already, but I think exploring the sheer range of industries that rely on these technologies would surprise you.
You're on. Hit me with some real-world examples. Where do we encounter these unsung heroes of the mechanical world?
Well, let's start with air compressors. They're the backbone of many industries. We already mentioned their role in medical settings, but they're also crucial in construction, powering pneumatic tools like jackhammers and nail guns.
Oh, that makes sense. I always wondered what gave those tools such a kick. It's all about compressed air.
Exactly. And in manufacturing plants, air compressors, power assembly lines, control automated systems, and even spray paint cars. They're also vital in the automotive industry, not just for manufacturing, but also for keeping those tires inflated.
Okay, I'm seeing a theme here. Anywhere you need reliable, easily controlled power, you'll find an air compressor.
Exactly. And what about vacuum pumps? They might seem less visible, but their impact is just as profound. We mentioned food packaging, but their role in food processing extends far beyond keeping chips fresh.
Oh, tell me more. I'm always up for a food-related science lesson.
Well, vacuum pumps are used in everything from vacuum sealing meat to dehydrating fruits and vegetables to even making cheese. By removing air, they help preserve freshness, extend shelf life, and enhance flavors.
Wow, I never knew my love for jerky had so much to do with vacuum pumps.
It's true. They're also essential in the pharmaceutical industry, used to create a sterile environment for manufacturing medications and even packaging life-saving vaccines.
Okay, so we've got air compressors powering construction and vacuum pumps preserving our food. What other unexpected places do we find these machines?
Well, how about in the glamorous world of light bulbs?
Light bulbs, really? I never would have guessed that.
It's true. Creating those incandescent bulbs requires a near-perfect vacuum inside the glass envelope to prevent the filament from burning out too quickly. Vacuum pumps are essential for removing air and other gases during the manufacturing process.
That's incredible. It's amazing to think that something as simple as a light bulb relies on such sophisticated technology.
It's a testament to how much we take for granted in our modern world. These machines, often hidden from view, play a crucial role in shaping our everyday lives.
It really makes you appreciate the ingenuity and engineering that goes into these seemingly mundane objects. And speaking of ingenuity, what about those artistic applications the article mentioned?
Ah, yes. Vacuum pumps are used in a surprising number of artistic pursuits. For example, they're essential for glass blowing, helping artisans shape molten glass into intricate forms. They're also used in stone cutting and carving, creating those beautiful, polished surfaces you see in sculptures and monuments.
So, from preserving our snacks to crafting works of art, vacuum pumps are the unsung heroes of creativity. I'm starting to think there's not much these machines can't do.
You're not wrong. And it's this versatility, this ability to be adapted and applied in countless ways that makes the world of air compressors and vacuum pumps so fascinating.
Absolutely. It's been an eye-opening journey so far, and I feel like we've only scratched the surface. But before we dive deeper into this rabbit hole, I think it's time to address the elephant, or rather, the vacuum in the room.
And what might that be?
Well, we spent all this time talking about air compressors and vacuum pumps as separate entities, two distinct tools with different purposes. But that whole DIY conversion idea, it makes me wonder if we've been looking at this the wrong way.
I see what you mean. It's like we've been so focused on their differences that we've overlooked a fundamental connection.
Exactly. It's like they're two sides of the same coin, both manipulating air and pressure, just in opposite directions.
Precisely. And that concept of duality, of seemingly opposite forces working in tandem, it pops up everywhere in science and engineering.
Now that you mention it, it does. Like in electricity, right? Positive and negative charges, both essential for creating a current.
Exactly. Or think about engines, internal combustion versus electric. They achieve the same goal, propulsion, through entirely different processes. And let's not forget nature itself. Predator-prey relationships, the balance of ecosystems, even the interplay of light and shadow duality is everywhere.
Wow, you're right. It's like those optical illusions where you can see two different images depending on how you look at it. Our brains are wired to categorize and separate, but sometimes the real insights emerge when we embrace those hidden connections.
Precisely. And that's what makes this deep dive so rewarding. We've gone beyond simply defining air compressors and vacuum pumps. We've uncovered a deeper understanding of the principles at play.
Absolutely. We've talked about airflow, pressure differentials, even the intricate manufacturing processes. But what I'll really take away from this is that sense of interconnectedness, that aha moment of realizing that seemingly opposite things can actually be two sides of the same coin.
And that's the beauty of exploration, isn't it? You never know what hidden connections you'll uncover along the way.
Couldn't agree more. So to our listeners out there, if this deep dive has sparked your curiosity, don't let it end here. Pick up a book, watch a documentary, or even try that DIY air compressor conversion safely, of course.
Here, here. Just remember to do your research and prioritize safety. But most importantly, keep asking questions, keep exploring, and keep seeking out those aha moments.
Beautifully said. That's a wrap on another episode of The Deep Dive. Until next time, keep those gears turning.